Hello guys, welcome to Code with BK. So today I'm going to solve another sample question for ISC Computer Science practical. Okay, so this is going to be based on numbers, integers, and so the problem goes like this. Suppose you have a number, say 123. So what you have to do is you have to convert each of these digits into its corresponding binary value. So this is 0, 1, or you can say simply 1, right? Then 2 is basically 1, 0, okay, and 3 is 1, 1, okay, and then you have to find a digit which has the maximum number of ones in its corresponding binary value. The answer would be 3 because it has two ones. And if they have equal number of ones, for example, if this was 5 here, so this would be 101. In that case, output the digit which is the largest, so output 5. Okay, so the question is convert each of the digit in the input given integer into corresponding binary value, then find the digit for which the corresponding binary value has the maximum number of ones. If two digits or if multiple digits have the same, then find the digit which is the largest, which is 5 and 5 here. Okay, so input is going to be n, and we'll keep the input between 0 to 999. So if n is the input, it has to be greater than equal to, or in fact 1, or we need multiple digits, so we'll take greater than equal to 99 and less than equal to 999. If n is out of this range, we are going to print number out of range. Okay, now so what we have to do here is, there you can divide it into maybe 4 parts, you can say. The first is the input, the second is the processing. In processing, we need to find a digits and b two binary. Okay, and then in third we can print. Okay, so I'm going to start writing the program, and I'm going to write the program on an editor compiler on it as well. So I'm going to say psv main. All right, now input is n, and since I have only one input, you can use buffer reader, okay, or you can use data input stream. You can use scanner. For I'm going to use scanner, the most comfortable to me. So scanner is equals to new scanner system dot, okay, and you can add import java.util.scanner. First thing, okay, is a comment. First thing is to read the value of n. So I'm going to say int n is equals to scanner dot next int. Okay, now what we have to do here is convert each digit into its corresponding binary values. For example, we took 153, so this is 1, okay, and this is 101, and this is 11, right? So I'm going to write a method first to take an integer and return its corresponding binary value as a string. Okay, so suppose my main ends here, so I'm going to say static string, because I need to return int to binary, right? And I take int n as digit. Okay, so the way to convert it is, you take an empty string, let's take string binary is equals to empty string, okay, and then finally I'm going to return whatever this binary comes out to be. Okay, now I need to write the code to convert n to binary. So I'm going to say while n is not equal to 0. Okay, so I'm going to say int d is equals to n%2, right? Binary is equals to d plus binary, that is concatenating this remainder I'll tell you how this works, concatenating this remainder D to the already accumulated binary value, and then finally doing, so the space is less, that's why I'm writing two statements as this, and finally you are going to do n by equal to 2, which is same as n is equals to n by 2, or just to be clear, I'll make it n is equals to n by 2, right? And then you finally return binary. So suppose if your digit is 5, right? So if n comes as 5, binary is blank, okay? So n comes as 5, binary is blank, while n is not 0. N is not equal to 0 is true, 5 is not equal to 0 is true. D is n% 2. n% 2 is going to give you the remainder when n is divided by 2. N is 5, 5 divided by 2 gives you 1. So binary becomes 1 plus binary, so binary becomes this, 1 plus blank, and it becomes 1. Okay, and n goes n by 2, so n becomes 5 by 2. This is integer division, so only the quotient goes back into the value into n. Okay, next we have n again, n is not equal to 0. Okay, we get d n% 2, so we get n 2% 2 is going to be 0. Okay, the old binary is 1, so I'm going to say 0 plus 1 is equals to 0 1, and n is equals to n by 2, so 2 by 2 becomes 1. N is not equal to 0 is 2 since n is 1. D is n% 2. 1 divided by 2 leaves a remainder of 1. So 1 plus 0 1 will give you 1 0 1. Okay, and then n is equals to n by 2 will give 0. We come back here, n is equals to 0 is false. So you finally return this return binary, which is 1 0 1 for 5. So this is how you convert an integer to its corresponding binary value. So this part is done. Okay, reading the value part is done. Oh, we did not check for the range. So what we are going to do, we are going to add the check for the range. So basically this is 3, this is 4, okay, and this is basically 2. That is checking for valid value. So I'm going to say if n is less than 99 or n is greater than the other range 999, I'm going to say SOPLN system.out.println number out of range. Okay, and I'm going to return, I'm going to stop. Okay, now I added a scanner.close. Previously you can add, you can ignore, it really does not matter. For you people it does not matter. So this is return, basically this is terminating the program when n is out of range. Okay, so what we have covered so far, we read the value of n, okay, then we check for the valid value of value range of n. If not, we print this number out of range, we return. Then we convert string into binary. We have written a method to convert string to binary that takes a binary value, converts it into takes an integer value, converts into corresponding binary as a string, and returns it. Alright, now we need to find binary equivalent for each digit. Okay, so I'm going to remove all this. Okay, I'm just going to remember this method into binary. Okay, and n. Okay, alright, so for this case we would need to know how many digits does this input has. So if you look at the range, so since n is greater than or equal to 99, so n takes values 99, 100 to 999. Okay, so all of them have 3 digits except 99. So you can add a check if n is 99, the number of digits are 2. For example, you can say int num digits, okay, is equals to, okay, if n input is 99, this is a ternary operator. Okay, if n input is 99, the number of digits are 2, else number of digits are 3. So this is a this is a smarter way of to go about it. Or if you want, we can write another method. Okay, I'll keep this as well. Okay, we'll write another method, or I'll just keep this here. I'll say int num digits is equals to n is equals to 99. In that case it is 2, otherwise it is 3. I'm going to comment it. Okay, check it later in the when I compile and run the program. Alright, so we can write another method to find the number of digits. Okay, static int num digits. Okay, I'll say int n. Okay, so I'll say int num. In basically I'll take function is, this is the variable name, so I'm going to say get num digits. I'll say get num digits. Okay, then I'm going to say int num digits is equals to 0. Finally, returning this value after finding it, I'll say return num digits. Alright, so there is a standard way of, there are two ways. I won't say it's a standard way. The way I used to learn was keep dividing it by 10 and go till it does not become 0, right? So take something like this, while n is not equal to 0, okay, and you say num digits plus plus, okay, and you say n is equals to n by 10. This will give you number of digits. Okay, this is simply saying that if you have say 782, right, so 782 is not 0, true. Okay, so what you do is num digits plus 1. So if you take num digits here, n not equal to 0 here, and n here. Okay, so num digits is 0 to begin with. Okay, n is not equal to 0 is true. Num digits plus plus, num digits becomes 1, and n becomes n by 10. N becomes n by 10. So n was 782. 782 by 10 integer division is going to give you 78. This becomes 78. N goes back here, since a while goes back to the checking condition again. N is not equal to 0. 78 is not equal to 0, true. Num digits plus plus, this becomes 2. N is equal to n by 10. 78 by 10 will give you 7. This becomes 7. Going back again, this condition is still true. Okay, 7 is not equal to 0. Then you have num digits plus plus 3. N equals to n by 10. 7 equals to 7 by 10. 7 by 10 is going to give you 0, since that's a quotient for this. So this is 0. N becomes 0. N is not equal to 0, false. Loop stops. You come here and then you return the num digits, which is 3. Okay, so this is how you find the number of digits in a number. Or the smarter, simpler way, if you are confused about this, you can simply do, okay, you can say take it into a string. You can say string t is equals to blank plus n and return n dot length. Very simple, very clear, very straightforward. You're just appending the number to a blank string and then finding the length of that string. Okay, no need to do this. Okay, so I'll tell you both the ways there. Alright, so we have into binary method, we had get num digits, we read the value of n and we got and then we need to find each of the binary value for each. Okay, now so I'm going to remember this method. Alright, moving on. So now I need to store the binary value for each of these. Okay, so I'm going to say int binary values. This is an array, and since each location in the array will be storing the binary value, and a binary value is a string, so I'm going to say string binary values equals to new string the number of digits. Okay, one binary value for each digits, which is num digits. So you can use this way, because this is what the range is defined, or you can use get num digits method. Okay, I'm going to show you both. Okay, string binary values, and then you have to find the binary value for each digit. So get each digit one by one. Okay, so the array for this, so this array is going to be something like this. Okay, initially, okay, you have to fill in the binary for it. 153, say this is the example. So 1 goes here, 101 goes here, and take another color for clarity. So 1 goes here, 101 goes here, and 11 goes here, right? So again you have to find each digit for this number. I am going to use the string method because that's easier. Otherwise, if you want to get each digit, you'll have to traverse the array in the reverse, which is going to complicate things. I will write the code for that. For example, I'll quickly write it. So if you want to find each digit, right? So what you can do, there are two codes you can use, right? So one way is, okay. So you simply say string strn is equals to blank plus n, appending the string to blank string. So 153 becomes 153. Okay, this goes from integer to string, and then I say for int I is equals to 0, I is less than this strn dot length, okay, I plus plus. Okay, I need to get the digit at this point, so I'm going to say char c is equals to strn dot char at I. Okay, so this is going to give me the ith character. Okay, so I for this case goes from 0 1 2, so I'll get character c as 1 5 3. Mind, you have to keep this in mind that these are characters, these are not digit yet. So in order to get the digit, we are going to do int d is equals to c minus 0. Since you know that characters are basically ASCII values, they have integers associated with them, and 0 1 2 till 9 are all consecutive ASCII values. So ASCII value of 0 minus 1 is going to give the value 1. That's why we get the digit as 1. Okay, we get the digit, and then we need to set the corresponding array location. I'm going to say binary values, okay, of I, okay, is equals to, that is this particular, for this particular digit it is going to be into binary, and you have to pass this digit d. Okay, this is one way. Okay, the other way is you have to get each and every digit. Okay, this is one way. This is a much simpler and clear forward way. The other is, okay, you have to use one of these. So I'm going to say int k is equals to n. Okay, while k is not equal to 0, I'm going to get int d is equals to k percent 10. Okay, and since this will give me the last digit, for example, if you begin with k as n, so k becomes 153. When k is not equal to 0 2 is true. When you take d as k percent n, you get 3. So you start getting the digits from in the reverse order. So what you have to do is you have to take an index that points to the rare last position in the binary values array. So I'll say index is equals to num digits minus 1. Okay, and then you have to say binary values of index is equals to same thing into binary. Okay, into binary, and you are passing the value d. Okay, and then since you are filling this array in this order, you are filling this first, then this, then this, then so you have to decrement the index. So you say index minus minus, and you have to remove this last digit from k. So you say k is equals to k by 10. Okay, so this is another way that you get the binary equivalent of each digit. Now, so our binary values array basically stores the binary value for each of this. Okay, each of the digits. Okay, now this problem is a little long and complicated because I'm trying to cover multiple concepts in a question. So I say, so that's why I wrote different methods, and I'm trying to make you understand different ways of doing the same thing, because these are the things around which your questions will mostly be asked, right? So this question might sound a little long, but this is like each step involves an own concept, right? All right, so moving on. So now we have binary values array that stores the corresponding binary equivalent of each digit. Now we just have to count the ones in each, right? I'm going to remove this. Okay, I'm going to take another array. I'm going to say int num ones, okay, is equals to new int num digits. This is basically, okay, this is basically going to store the number of ones for the binary equivalent of each of these digits. So number of digits, so 3, so 3. All right, so number of ones is for each of this digit, and I'm going to say is, I can write another method to count the number of ones. So I'm going to say static int get num ones string binary value. All right, so I'm going to say int num ones is equals to 0, right? So while so since it's a string, I can iterate 0 I is less than binary value dot length I plus plus. So if this is a 1, I increment. So if binary value dot caret, okay, at this particular position I is a constant 1, okay, since you get a character constant when you do caret. This is binary value, okay. I say num ones plus plus, then finally return num ones. All right, okay. So this will give us the number of ones for this corresponding binary value. So this is, again I'm going to type this. So if you want to verify this part, just go to the end of this video where I have written this code if this is not clear. Alright, so we have got num ones, right? And then we have to find the digit with the maximum number of ones. So let's just store them. I'll say for int I is equals to 0, I is less than num digits I plus plus, and I'm going to say num ones of I is equals to get num ones. This method pass the corresponding binary value for this ith digit. So I'm going to say binary values of I. Okay, so passing the binary value for this ith digit. So basically I'm just keeping things linear, so that this is 0th digit, this is 1, this is second. So the binary value for this is 1, this goes here, so you get number of ones as 1. For 5 you get 2, and for 3 you get 2, right? Now you have to find a digit with the maximum number of ones in its binary value. So suppose I'll say int max digit index, okay, index is equals to 0. Suppose my first digit has the maximum number of ones, okay. So I'm going to compare and check. For int I is equals to 0, I is less than number of digits I plus plus, okay. If max, or since I have already considered 0th index, I'll start with 1. Basically what I'm trying to do is, once you find a number of ones for each of these binary values, you get an array like this: 1 2 2, right? So 1 ones, 2 ones, 2 ones, right? And then I suppose that this is the one with the maximum value in this array, and then I compare it with the others. So I've considered maximum digit index as 0, then I'll compare it with the others, okay. So if num ones at max digit index, okay, if number of ones at max digit index is less than number of ones at ith location, okay, ith location, then in that case num ones, in that case max digit index becomes I. Okay. The other case, when number of ones are equal, else if num ones in max digit index, okay, is equals to num ones of I. Okay, so you have to pick the one which is the greater digit. Okay, so remember we took str n as the string form of the number, right? So I'm going to compare the corresponding digit. So 0th position for this is going to give me 1, first position is going to give me 5, second position is going to give me 3. So if two are equal, I'm going to compare if str n of max, so you update this max digit only if the ith digit is greater. Okay, so I'll say if str n of I is greater than str n of max digit index, oh, str n dot caret, so this is not an array, sorry for that. So if str n dot character at I is greater than str n dot char at max digit index, okay, then in that case you set max digit index equals to I. Okay, this is an if condition, else if closes and for loop closes. All right, so again, this is just to, you might, this is not very clean because I don't have a lot of space, but you can just always go, I'll write the code at the end, you can check there. Final thing now is you get the max digit index. All you need to do is print finally sopln strn of dot caret at max digit index. Simple, that's it. Okay, this is what you need to finally print. Alright, so this was pretty long and complicated, but I'm going to just show you the code, okay, and you can just read the entire code and go through the multiple concepts involved, okay, because if you want to get the ith digit of the number, how do you do that? Okay, so let's go to the coding now.
Okay guys, so this is the code to the problem that we just discussed, and this is the exact code that I've written. Okay, the one I explained on the board. So I'm going to run it and test, and then I'm going to show you like these were the alternative ways to find the same solution to solve the same problem. For example, to get the number of digits, we could have used just these two lines instead of all this. So I'm going to uncomment and check that as well. And similarly, for finding the binary equivalent for each digit, okay, this is another method for that. So I'm going to uncomment this and check as well, right? So let me run this. So starting with the first example, which was 153, I get 5, which is the correct answer. I say 99, I get 9. Okay, both are the same digits. Then I say 90, number out of range. All right, and if I have say 1000, number out of range. All right, so let's take a number where all the digits have one single one in their binary equivalent. So 1 to 4. So 1 is 1, 2 is 1 0, and 4 is 1 0 0. So I should get 4, which is the right answer. And in case I have 157, so 7 has 3 ones, so 7 is the right answer. All right. I'll take another example, 100, and 1 is the right answer because zeros have no ones in their corresponding binary equivalent. Now I'm going to come in this part, okay, to find the binary equivalent of each digit. I'm going to use this part, and similarly for the other one I'm going to use this, all right, to find the number of digits, and I'm going to come in this part. Okay, Now these are very important concepts when you are preparing for practicals, because this is a very important piece of code you can use. You can remember this is another one. This is not so important because it's just simply iterating and finding the number of ones. Okay, but finding number of digits and getting that binary equivalent are two important concepts I would strongly suggest you should remember when you are appearing for the practicals. All right. Okay, so there is another this warning because scanner is not closed because I did not add scanner.close in the end. Okay, so you will see that warning will disappear. Okay, and this warning appears because I need to close the scanner again before terminating the program, because I'm terminating returning from here, so I need to close the scanner. All warning is gone, no warnings here. Okay. Okay, so using the alternative methods, I'm running this program again. For 124 I should get 4, for 153 I should get 5, for 171 I should get 7, for 100 I should get 1, for 90 I should get out of range, for 99 I should get 9, and for 111 I should get 1. So this was the solution to the problem that we discussed, and I'm going to write the solution for this very question in a very optimized manner. This is a very naive approach. There is no optimization, there is no thought given into like how you can simplify the solution. So I'm going to write a much simpler, shorter code for the very same question. Okay, and then you will understand how you can dig down a problem if you give some time to this. Okay, so I hope this video was helpful. So this was majorly to brush up certain concepts, right? So do like this video, subscribe to this channel for more such videos, and thank you for watching.